Alright, in addition to the Pythagorean theorem, you can use some rules for special right triangles to help you find missing lengths of sides. So triangles have three sides. If you know one of the sides, you can use the rules to help you find the other two sides. Now, this only works for two special kind of right triangles. Remember, the sum of the angles inside a triangle have to equal 180 degrees. So you've got 1, 2, 3 angles together that need to equal 180 degrees to make a triangle. Well, these are special right triangles. So one of your angles is going to be a right angle, which is 90 degrees. But the other two angles have to be 45 degrees for this rule to work. If one is 46 and the other one's 44, it doesn't work. It has to be 45, 45, and 90. And the rule is that the length of the hypotenuse, remember the hypotenuse is the slanted part of the triangle, is always going to be square root of 2 times larger than whatever the leg is. And so the legs, if this is the the right angle, the legs are what come off of the right angle. So you've got a leg here and the leg here. And both of these legs are the same. So if this one's 8, then this one's 8. If this one's 6, this one's 6. If this one's 24, this one's 24. They're both the same. And the way I remember it is it because it has two angles that are the same measure, then the two legs are the same measure. That's kind of an easy way to kind of help you remember that and keep it straight. But whatever the leg is, the hypotenuse is going to be square root of 2 times larger than either one of the legs, because the legs are the same, and it's just proportional. So if it gets larger or smaller, this is just proportionally how many times larger the hypotenuse is than the legs. The other rule is for the 30, 60, 90 degree triangle. And so here again you've got your 90 degree angle, your right angle. This is a 30 degree angle, and these are not drawn to scale, by the way. Sorry, that looks bad, but these are not drawn to scale, so don't overanalyze the pictures. I mean, they were drawn closely but not completely to scale. So in a 30, 60, 90 degree triangle, again you have your right angle, so these are your legs. There's one leg that's noticeably shorter, and that's A. The one that's smaller is your A. The longer leg is going to be A times square root of 3. So whatever your shorter leg is, multiply it by square root of 3, and that's the longer leg. And then your hypotenuse, remember, which is the long slanted part, is always going to be 2 times larger than the shortest leg. Alright, and this is proportionally, again, no matter how big or small, these are the proportions so that you can use them to help you figure out the lengths of the missing sides. So let's do a couple of examples. Alright, this first one, this is a 30, 60, this is a 45, 45, 90 degree triangle. And so again, you're going to have two legs. Here's your right angle. You've got a leg coming off here, and you've got a leg coming off here. They're both A's, and then your hypotenuse is going to be A square root of 2. So if this leg is 13 meters, that means that this leg is also 13 meters. And if A is equal to 13, that means the hypotenuse is equal to 13 square root of 2. Now, if this could be simplified, I would want you to simplify the radical as much as you can, but this example, this cannot be simplified. So there's nothing that you can do here. This would be your answer here on each of these. And this is meters. Okay? Here's another example of a 45, 45, 90 degree triangle. And again, you've got your right angle here, so this is a leg and this is a leg. And your hypotenuse is equal to A square root of 2. Well, if it's A square root of 2, here's your square root of 2, so that means A must be equal to 8, and I didn't put a unit on there. We'll call that meters. Alright, so that means A is equal to 8. So that means this side is 8 meters, and this side is 8 meters. Alright, now let's look at a 30, 60, 90 degree triangle. Again, with a 30, 60, 90, here is your right angle, so that means this is a leg and this is a leg coming off. And your shorter leg is going to be represented by A. Your longer leg is A square root of 3, and then the hypotenuse is equal to 2A. So when I go through and I solve, if this side is 6, this is my A side, that means that A is equal to 6. So the longer leg side is going to be 6 square root of 3, and that's going to be meters. And then my hypotenuse is 2 times A, which means it's going to be 2 times 6, which is 12 meters. And then the last example, this is another 30, 60, 90 degree triangle. Again, we have our right angle, and so that means that this is the leg, this is our shorter leg, and then this is our longer leg, so that's going to be a square root of 3. And then our hypotenuse is equal to 2a. And so if I know that it's 2 times a equals 22, that means that a must be equal to 11. So I can use that to help me down here. That means a is equal to 11, and we're going to put our meters because we want to label our units. And the length of this longer leg here is 11 square root of 3 meters.